Hello everyone, welcome back to school and welcome to the class ECE317 Digital Signal Processing. So new semester start, right? You just finished the break. I hope you all have had a wonderful the winter break, the holiday season, and we will have a wonderful new semester. Alright, no problem. And so today we will just go over the syllabus, give some introduction to the course. Alright, ECE317. Here I open the blackboard here. It's a ECE317 Digital Signal Processing 1. Okay. Yeah, in your side, when you open the blackboard, maybe it looks a little bit different, but the material will be same. Here we have some items here. The welcome, this is created by the university, and then announcement. When I have some information I want to share with you, I will put the announcement here, like a new announcement appear below here, this line. I will put the announcement here, and you can check what happened from this announcement. And then syllabus and policies. Okay, this is an important thing. This is a syllabus. Is this small? The letters, or can I make it large? Okay, this looks better, right? Alright, syllabus. So this is a course with 4 credits. That means we have labs. And here is me, Dr. Ning Jing. You can just call me Ning, that will be fine. I'm Ning Jing. And lecture time, there will be Monday, Wednesday, Friday from 10 a.m. to 10:50 a.m. So 50 minutes. But this is an online course. It's a synchronously course, so you don't need to attend this exactly on this time. Here we have this time here. We have several features. The first one is before this time. I will post. Let's see here. The lectures will be posted in YouTube, and before this scheduled time, they will be posted. So you can watch the video from YouTube during this time. Yeah, this is a guarantee. You can have the video. You can watch the class. And usually I will post it earlier, and hopefully, I think almost all the lectures I can do this one day before. So like today is a Monday, so Monday's class, the movie will be posted on the evening of Sunday. So that means in all the time in the Monday, you can watch it. Yeah, it doesn't matter, morning or evening. Yeah, depends that which time do you like. Alright. So you can change it. But here I want to mention, you can watch it anytime, but don't move these. Like you watch it, okay, I can watch it anytime. This is Monday class, I can watch it next week. Is that alright? No, that's not good. You will try to finish every class just on time, on the same day. Like you can watch it in the evening, right? This is the morning class, you can watch it in the evening, but not too late. If you move this to the second day, maybe still work, but you have some risk. If you always move it back, then in the final, when you reach the almost the end of the semester, you will find, I have like 10 more lectures I didn't watch the movie, but the exam, that will be 2 days later, we will have final exam. I still have 10 lectures, I didn't see it. Okay, so don't do that. You try to finish, watch the class, study the class, follow the schedule. So every Monday, Wednesday, Friday, you will have some new classes, and try to finish it in the same day. And then in the second day or the rest of the same day you can do some review, finish the homework, and something else. And also we have labs. Now this is lecture time. You also have the lab. Lab will be on Tuesday or Thursday. Each of you will be different. Totally we have 2 or 3 sessions, lab sessions. So yeah, and the lab session you also need to follow the schedule of the lab. Yeah, you can do your lab experiment with a flexible schedule, but not too late. Not move it to 2 or 1 or 2 days later. Try to finish everything on the same day. All right. And other than the lecture time, I will also use this time for exam. We will have midterm exam, one midterm exam. Midterm exam will be during this time. And then the final is also an exam. The final exam will be on a schedule which is given by university. That time is based on this lecture time. Based on this lecture time, they give us exam time, and then we will have the final exam at that time. All right. Okay, so this is a lecture time. Then office hour every Wednesday. I put here Wednesday 4 to 5 p.m. and I'm not so sure. So if you have any requirement, you think this is not good and which time is better, you can give me some suggestion. I will see. If only few of you guys want to change, I will just keep this. All right. And hopefully this works for all of you. Right, it's a Wednesday 4 to 5, or maybe we can put it even later. Then all of you can have time to go to the office hour. The office hour, we will have a Zoom meeting, and if you have any question, you just go to the meeting, then you can ask me. All right. Okay, so this is the lecture. What else I will see? Okay, so for this time, for lecture time, most of the lecture, I just record the lecture before the class so you can watch it during this time. And in some cases, I still use this time as a meeting, as a Zoom meeting time. For some, I need some review, or some discussion, I will use this time. All right. Okay, then my email, that'll be normal. Then TAs, I will put the information later. TA also, they are also students. They are the new semester. They just coming back. Yeah, similar with you guys, but they are graduate student. Okay. Then something about the course itself. Suppose you already have the fundamental in ECE310, right? Something about the system, signal, some transform like Z transform, Fourier transform. Actually, you have more. In this course, we consider digital signal processing. 310, you consider signal, all kind of signal, right? Continuous time or discrete time. Then the textbook. Here I give a link here, the name, the order, and the link. If you want a paper book, then you can purchase by yourself. And if you can accept this digital one, you just go to the link. Let me see. I need to click it. Sorry, this doesn't work. Okay, so I need like this, copy and put it here. I see it. This is a textbook. You click on the name, the title is different color, it's blue, right? Title, click it. Okay, get. You click get, then you can download the book. It's a digital version. All right. Yeah, this is textbook. No, I just closed it. This is textbook. Let me go back to the syllabus. Okay, and also you need a textbook and MATLAB, or the lab experiment. You need MATLAB to do the lab experiment. And the course description. Okay, just one sentence. It's a introduction to discrete time signal processing. All right. For details, you will know during the whole semester. All right. Yeah. And here I explained everything. You can find all the information, everything. You will go to Blackboard to see, to find all the necessary information, necessary stuff like the video, like the homework, like the solutions, some tables, some lab instructions. Yeah, everything you can find from Blackboard. So always check it. Always check it. All right. Then for the final grade, so like A, B, C, D, F, right? And the level is just normal. 90 or more for A, 80 to 90 for B. Actually, to 89. I put to 90. Should be 89. Then 70 to 79, 60 to 69, right? Each level. And this point, like here's 90. Which number is this 90? 90. This 90 is a combine of these four things: the lab experiment, homework, midterm exam, and the final exam. Lab experiment we have 20%, 25%, and homework is also 25%. And then exam, midterm is 20, and the final is 30%. Then how to do it? For lab, you need a MATLAB to work on it, and the first lab will start in the third week. Okay, third week. So first 2 weeks we do not have labs. And for lab, you can work as a group, 2 or 3 work together. So if you work together, you need to find your own way to communicate, right? To talk to each other, to discuss each other, to find a way to solve, to finish the experiment. And here actually we have a requirement for lab group. If you 2 or 3 work together, you should be in the same group, in the same lab session. We have several different lab sessions, right? So if you work together as a group, then you should be in the same group. And then you can submit a report. Each group just submit one report. Write down all the names of you guys, right? And homework is similar. You can also work as a group, 2 or 3 work together. Here you are not required to be in the same lab session. Lab session just for lab. For homework, you can work together with anyone in the class. Right? Not necessary to be in the same lab session. Right? Different. Lab is lab. Homework is homework. Homework is for lectures. And then midterm and final, they are exams. Exam, you cannot work as a group, so individually. Each one will finish your exam by your own. And the time is about in the 9th week. We will see. So how the class processing, right? Procedure. And then the final exam will be in the final week. The university will give us a schedule. All right. So this is for the grade. Okay. What else? Yeah, and something else you can read. The university, they give a lot of information other than the courses, just course itself, like communication with me. Okay, don't call me in office phone. I'm not in office. Anyway, yeah, you can read this part later. All right, this is not. I want to explain. I will not explain it here. Let me make this zoom. Okay, this is a syllabus. The most important thing is the homework. The textbook, not homework. Textbook. All right. Okay. Then other than the syllabus, we go back to here. Syllabus, Then the lecture material. Lecture material. From here you can find, okay, we have table. The whole class, you need some like a calculation you can based on the tables, the Fourier transform, the Z transform. You can use these tables. I already put it here. Then videos and notes. So each lecture we have a video and notes. Yeah, now is nothing. I just have title here, and so because I'm recording, I'm recording the first lecture. After I record the first lecture, I will post it here. Then when you go to the Blackboard, when you visit Blackboard, you can see this lecture here. All right. You need to click on this video and notes. Then you can open the new space. Then you can see, okay, the first week Monday's lecture. Then the notes is inside there. All right. Yeah. So week 1 and 2, and later we will have week 2, week 3, week 4, week whatever followed, right? Okay, so this is the lecture and the materials. And then lab material. Lab material, now I have lab menus. You click on it. Yeah, this one we have stuff. I put it in, yeah. Okay, then lab 0, 1, 2, totally 8 experiment until lab A. Right? Lab 0 to 8. 0 is kind of just try to familiar with MATLAB, some very basic things, right? Then lab 1, 2, 3, 4, 5, 6, 8. So totally we have 8 experiment. They will work weekly. So we start from 3rd week, and I think which lab you need 2 weeks, 4 or 5. Lab 4 or lab 5 you need 2 weeks. And in the week we have midterm exam. You don't need to work on lab. So totally this is 9, and 1 is 2 weeks. So we have 10 weeks we need a lab, and first 2 weeks we do not have lab, and 1 is for midterm. So when you finish all the labs, it should be about like 13 or 14 weeks. Totally we have 16 weeks. That will be the final week, right? Okay, so this is a lab, and every lab, for example, the first lab will be in the 3rd week. So in the 3rd week you will try to work on lab 0 and submit your report in the 4th week. The due time of the lab, it is just the lab session time, right? Everyone, you have your lab session. So totally we have 3 different lab sessions. So you have 3 different time. Different of you guys, you will submit your report in your lab session time. All right. So first week, like a 3rd week, do the lab. Then 4th week, submit the report. All right. So this is a lab. Then the homework. Yeah, now is nothing. You click on the homework and the exams. I will post the homeworks here. Homeworks, exams, I will post it here. You go to here, click on the homework, then you will see what are the problems, what is the due time. Okay, so you try to finish your work by the due time and submit it, right? Submit it by the due time. For the grade, if you are late, you can still submit, but I will drop you some point. If you just late, you will lost 10%. For example, like this homework totally is 40 point. If you are late, the 4 point will be dropped from your work. And okay, but this is the case you submit late, but before the solution posted. Yeah, I will also post the solution. Every homework after the due time, I will post the solution. Maybe just 1 day break before the solution was posted. So in this day, if you're late, you drop 10 point. After I post the solution, I will drop 40%. So that means, like for example, homework, you have that homework has 50 points, then you just late, then drop 5 points. If you rather late after the solution posted, then 40% of the 50, so 20 points will be dropped. Alright, so yeah, you should keep in mind, try to finish all the homework. And lab is similar, but lab just, if you late, drop 10%, because no solution will be posted for lab. Yeah, so keep in mind, you try to finish everything on time. But of course, if you have some kind of reason you really cannot submit on time, you can submit it late. It still give you some point, right? It's better than do not submit. Okay, so this is the homeworks and the exams. Then the tools. Okay, in tools we have here's a lot, right? Here are a lot of tools, and I will use 2 of them. One is Piazza. We use Piazza as a kind of a discussion board. So when you have a problem, you post the problem in Piazza, and me and the TAs, when we see, okay, there are some problems, then we try to explain it and give some answer. So this is a Piazza. It works like a discussion board. And the second one is a Zoom meeting. Here, Zoom meeting. When my office hour, TA's office hour, we are use Zoom meeting. And some review session, I will arrange some review session, also use Zoom meeting. Alright, so we need a Zoom meeting, and also we use Piazza in the tools. Okay, so this is a Blackboard. What else? Oh, they put the Zoom here. Okay, so you can also find the Zoom from this menu. You do not need to open the tools. You just open the Blackboard, open the course. You will see Zoom here. Okay, so this is the syllabus. Alright, what else? So here, this is an online class. This is a problem. I can't reach you. So if you have any question, email me. Alright, email me, or you just go to Piazza, post your question in the Piazza, then I will answer you. Alright. Okay, so this is just a very basic instruction about this course. Now about the material of the course. So what is this course? We know this is signal processing, right? Digital signal processing. So the whole course will work on digital signal. You see here, digital signal processing, right? So what is digital signal? So today I just show you a little bit about what is a digital signal. Okay, let me go to here. This is a ECE317, the first week, Monday's class. And this is just an introduction. And here I just want to discuss one topic. What is a digital signal? Digital signal has 2 features. The first one is discrete time. So we can write it as like x of n. So it is a value depending on time n. Now n is the time, but this time is a discrete time, right? Discrete time, not all the time. Just if this is the n, you can have 0, 1, 2, 3, right? You will not have time between all these numbers, all the integers. You only have integers as time. You do not have time like a 1.5 or 2.3. No, you won't have those numbers as time. N must be integers. So time, the discrete time, we call them discrete time, right? And the second thing is a digital value. for example, like a pi. This is a real value. Then we represent it as 3.14. This is digital value. Digital value. Pi will be 3.14 blah blah blah. There's a lot, infinite numbers after the dot, right? Infinite digit, infinite. And the digital one, you only have finite length. So we call it digital one. So computer cannot do any work like with after the dot you have infinite length for the numbers. No, they only have finite. They only have finite length. Actually, they are not. They are in the 0 1. It's a binary number. So not in this way. There will be some like a 1 plus 1 over 2 plus 0 over 4 plus 1 over 8, something like this. This is a different number, alright. Something like this. They can only in computer they can only represent number in this way. Use 2 as a how to say? It's a binary, right? It's a binary, 0 or 1, only 0 and 1, right? So digital signal, we have these two feature. But in this course, in most cases, you just pay attention on the discrete time. That will be fine. Digital, that means maybe you have some small error, like a pi and 3.14. You have some error, right? After 2, you have some number. You drop them away, so you have error. This is error, but the error in most cases is small. So you can, if you are not working on some special problem, you can just think, okay, discrete time is enough. Digital just could be any number, not really any number, but the error is very small. You can don't think you can ignore it. Okay, so this is digital signal. Now, how to describe a digital signal? How to describe digital signal? We have several ways. The first way, formula. For example, x of n equal to 2 to the n. This is the formula. By this formula, you plug in n, then you can know the value. Like n, I list the value. N equal to like -2, -1, 0, 1, 2, 3. Then x will have value. This is 1 over 4, 1 over 2. This is 1. This is 2, 4, 8. So you can find the value of x for any n. Like n is 10, here will be 1k, right? So 1024, right? Something like that. So you give the value of n. You plug in n here, follow the formula, you can have the value of x. This is very convenient, right? You have the formula. You just, okay, you know the time, then you know the value. And the second case, list the value. List the value like x equal to, for example, this is signal, right? I list the value here. You have 1 over 4, 1 over 2, 1, 2, 4, 8. More, you have more. So those you need some dot to represent. Some dot in the front, some dot in the back, and you know this value. And you also need to indicate what is the value of n. So you need to put some like n equal to 0. If you want, you can also write in this way. N equal to 3 is also fine. You know 1. Okay, this is n 0. Then next will be n equal to 1. The other next will be n equal to 2, right? And so on. So you indicate 1, that will be fine. So this is list of the value. List of the value. It is not as seems like not as good as a formula, but in real application, in a lot of cases, you can only list the value. For example, you take the temperature. Every day the highest temperature of every day, then you have a sequence of number. That is a signal. That is a discrete time signal. Right? Every day you have one number, and that number is hard to give a formula. Right? You record it, the next day will be another number. It's hard to give a formula. It's hard, no formula. I would say no formula. It's kind of always changing. They have some regulation, but not exactly. Like during days, the highest temperature might be around 35 degrees, something like that. Yeah, but every day is different. You cannot give like a formula, right? So in this kind of case, you can only list. You have no formula. You can only list the number. Okay, the third way is a graph. So it's like this one. I give a graph. Here's this axis is n, the time, and this axis is x, the value of the signal. And okay, for different n, you have different value. Now different n 0, I have 1, and 1, I have 2. Then I have 4, I have 8. Oh, I need more space. Anyway, you know what I'm doing, right? It's here. 1, 2, 4, 8. And the other side I have half, 1/4, and so on if you want, right? So you can give a graph for the signal. All right. So to represent the signal, you have 3 different ways: a formula, a list of number, or give a graph. Okay, so this is what we will do for a signal. And what is a signal? This is a signal. This is digital signal or discrete time signal. And we can also represent these kind of things in the computer. So as I explained in the syllabus, you need a MATLAB. So here I can show you in MATLAB how to give a graph of a signal, how to represent a signal. Okay, MATLAB. Yeah, this is an old version. It's a version in 2001. I don't want to update. Update, that means strong functions but slow speed. And here the basic function for me is enough. Okay, for example, the signal I try like, okay, I use a function. I put it here. I use a file, then the new M file. Then I write the code in this M file today, and we can read on it. We can run it anytime when we want. I need to put these in a folder. Here I can choose the folder. This is a ECE317. ECE317 here, MATLAB. Okay, this one. And I think I already have something. This is last semester. Now I added lecture 01 for Monday. Okay, .m. Added this one. Oh, it's start running. Anyway, yes, it already fine. Okay, all right. I have this one. Then as the first one, I think like I give a time interval from as we did here. Time run from like here from -2 to, for example, 10. 10. -2 to 10. So I give a time interval. This is n. Then I have x, which is 2 to the n. But this n is a list of number, not just one number, right? So I need to put dot before the power. This notation, it means power, 2 to the n. But n is a vector, not single value, so I need to put a dot. That means I have the power element by element. Okay, this is X. Then I just plot it. You can see plot X. Okay, let me run F5. Oh, I need to save it. I need to save the file. Yeah, it's already here. 317 my left. See. Oh, I see. Yeah, it's increased to 1000. Yeah, it's too large. Okay, another way to plot it, I use this one, stem. Okay, F5. Yeah, I plotted the value like this. So from, oh, I didn't put the N. Yeah, I need an N. If I do not put the N, here, then this axis will start from 0. But actually we start from -2, right? So, alright. Now when N is -2, its value here should be 1/4. It's very small. And when N go to 10, it will be 1024, right? So like this, you can see the graphs to see the signal. And actually I have another signal here in my folder. Let me see. LS or list the value files in the folder. Yeah, I have hello.wave. I say hello to all of you. Alright, hello, and I recorded it here, and I can open it and to see what it is. So this is the function word like this. I need a Y. I need to know what is the frequency and what is a bit. Okay, equal to wave read. My wave file, my audio file of the voice is a wave, so I use wave.read. This is a hello.wave, WAV. If you use like MP3, you need to use different function. You can search Google open audio file. They will show you what kind of function you can use. This is just one of it. Okay, then I get a Y. Here we have 3 numbers. We can see what is FS, we can see what is a bit, and then we can hear the sound of it, sound of Y with frequency FS. Alright, okay, wrong. Hello. You see, hello. I say hello to you guys. And here FS is the frequency. That means in each second how many numbers do we have. So this is each second for this voice, each second we will have 44,100 numbers. Yeah, a lot of numbers in each second. This is frequency, right? And the bit, each number is a 16-bit. So here you see Y. You see which one? Y is a voice. It is a list of numbers. Each number contains 16-bit. So we use 16-bit to represent the number of the sound. Can I double click to see it? Oh, it's too large. This size is too large. But we can see some of the value of Y. For example, Y from like 2000. We can watch like 10 values, 2010. So by this way we can display 10 values of Y from 2000 to 2010. Oh, it should be 11 values. Okay, we can see some values, right? Yeah. So Y is a list of values. Actually, this is a discrete time value, and we can also display it in a map, in the map way, in the graph way. So we can just plot Y. You can see what it is. Wrong again. F5. Hello. The graph is here. Okay, here you see. If we watch the, this is the way. Same like this. All the values you give a point, then you have a graph. So now the graph is here because we have a lot of data. How many days do we have? You can see that. How many days do we have? We have 34,843 numbers. This is a totally, I don't know, it's like less than 1 second, but we have a lot of number here. We can display the number in a graph. It looks like this, and we can also give the sound and play it. I can play it. Okay, and here, so overall this course for digital signal processing, we need to do work on the signals. What is signal? So the voice is kind of signal, and we have more. I just know like the temperature of every day, their signals, stock market, the price, their signals, and anything anything, you measure some values, then when you have a sequence of values, there is a signal. When you talk, right, the voice is signal, and you can do some work on it. Actually here we can do a simple thing, like here I have Y is a voice, the date, right, all the date of this voice coming to Y, and when I play it, I use Fs as a frequency. If I change the frequency, what will happen? Like I use a lower frequency, 0.9. Alright, you can see what will happen.
Hello.
It's still me, but not exactly me, right? The voice is lower. Yeah, it's like 5. What happened? Oh, this is too low. That's 7.
Hello.
Oh, hello. Oh, right. Yeah. Okay, if I make it higher,
Hello.
I'm talking. Okay, try again.
Hello.
Oh, it sounds like not me, huh? Some young man or some kids, and even higher. I put 0.3.
Hello.
That's just kids, right? Like a girl, not a man. Like 0.5.
Hello.
Oh, this is baby sound. So yeah, you can change something to see what happened. All right. Okay, and I can also change something else. Like now is this is original voice, right? But this is Y. I take square. What will happen? Take square. What will happen? Oh, nothing. Alright, now take square. I times 1.2, 20% more.
Hello.
Something similar. Just the volume will be like a 0.5. The volume will be low.
Hello.
Slightly. I use a 2.
Hello.
Oh, the volume is 0.1. Okay, here, right? So things like that. You make some change on the signal. You can make some change on the signal. Then you can have different result. All right. Okay. Then that's all for today. Let me see. We go over the syllabus and also explain what is a digital signal, discrete time signal, and there we are. Then my camera doesn't work. Yeah. Then we will meet next time is Wednesday. Next class is Wednesday. All right. So by Tuesday, I will post the video of Wednesday's class. Okay. This one is for Monday's class. Yeah. Okay. And see you next time. Bye bye.